Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous lecture we have got to know about the S block element, that is group 1 elements, and that were known as alkali metals. And now we are going to talk about the group 2 elements, that is alkaline earth metals. So what are alkaline earth metals and what are the different elements that consist in those group? Let me talk about that, as well as we are also going to discuss about what are the periodic trends of those elements in the periodic table. So now let us discuss about group 2 elements, that is alkaline earth metals. So talking about the alkaline earth metals, the name alkaline earth metals have been came because of those elements. They are been found on inside the earth crust, and that's the reason they are known as alkaline earth metals. So what are those compounds? Let me discuss about that. And those compounds are beryllium. We are representing it with that is Be, beryllium. Then it comes after it, that is magnesium, then calcium, then it's strontium, and after that it's barium, and ultimately we could say the next is radium. So these are basically the six elements that belongs to group 2, and the reason behind they are known as group 2 elements because if we talk about the position of these groups, they are being at the extreme left section, and that is the S block, as well as talking about the position of this. Actually these are basically belonging to the second group, and because of which they are also belonging to S block. And let me talk about the next one, that is what would be the general electronic configuration. So let me talk about one of the example, like suppose if I'm talking about beryllium. So beryllium has an electronic configuration that we could write, but unless we know the atomic number, we can't write the electronic configuration. So beryllium has an electronic configuration that we could write it as 4. So how can we represent it? So according to the electronic configuration, we know that it could be represented as 1s2 and 2s2. But if you observe, that is the last electron, it enters in the s orbital, so that's the reason it makes it to be called as an s block element. And but especially if we talk about the group, so therefore it belongs to the second group. And in the periodic table also, in the chapter periodic table, we have also discussed about how can we predict whether a particular element is belonging to which period or which group. So in this case, basically if we observe, that is the last electron enters in the second shell, and that's the reason that is the last electron, it enters in the s orbital, making the s orbital to consist of 2 electrons. And that is how we could say that the beryllium, magnesium, calcium, strontium, barium and radium, they are belonging to group 2 elements. So this was regarding the alkaline earth metals, and now let me talk about the periodic trend. So as we have discussed earlier also, that is in periodic trend we discuss about the few points, and those are basically atomic radius, ionization enthalpy and electronegativity. Especially these are the 3 points that I'm going to discuss about. So let me talk about the atomic size or ionic size. So as we go down the group, that is from beryllium to radium, so as we know that the atomic number, it goes on increasing. Suppose for beryllium it is 4, and for magnesium it is 12, and for calcium it is 20. So as we move down the group, then what we observe that is the atomic number goes on increasing, and thereby we could also say that the number of shell also increases. And that's the reason that because of this rapid change of the atomic number that we could observe from beryllium to radium, that plays a very vital role in increasing the radius or increasing the atomic size. And that's the reason as we move up to down, the atomic size increases. So this was regarding the atomic size, or we could say ionic size, or same it is applicable for the ionic radius also. So talking about the second trend, and that is the second periodic trend, or where we could find change, and those is basically ionization enthalpy. So let me talk about the ionization enthalpy. So ionization enthalpy, as we know that it is the minimum energy that has been required so as to remove the loosely bonded electron of an atom. So even if we observe, that is talking about beryllium, and we are comparing the ionization enthalpy of beryllium and radium. So beryllium is the one which is the smallest or the element which has basically a smaller size, and that's the reason that we could say that the last electron is basically, it is very much closely bonded to that of the nucleus because of the increase in the nuclear charge. And talking about radium, because radium has a that is, it has more bigger or larger atomic size compared to that of the beryllium. Obviously the last electron, it will not have that much of affinity towards the nucleus of radium. So that's the reason it is very much easy to remove the electron of that is radium, and that's the reason radium is been acting like a radioactive element. And talking about barium, it requires more energy. So in that perspective, we could easily say that the ionization enthalpy, it decreases down the group. That means it would require more energy so as to remove the last electron of the beryllium, and it would require very much less amount of energy so as to remove the loosely bonded electron of radium. So this was regarding the ionization enthalpy. So now let me talk about that is electronegativity. As we have already mentioned about this thing, that is these are the s block elements, and those elements are basically more electropositive. But if we compare it with beryllium and if we compare it with radium, and as we know, that is the beryllium has a very smallest atomic size compared to that of all the group or all the elements belonging to this group 2, and that's the reason that it is very much less electropositive. While talking about the radium, it is basically it can lose electron very easily, and that's the reason that it is more electropositive. So this was regarding the electronegativity. So we could easily say that the beryllium is basically more electronegative because of the smaller size, and talking about the radium, it is basically less electronegative, or we could say it is more electropositive. So this were the few periodic trends, as well as a few mentioning about the alkaline earth metals. So that's it. So thank you friends for watching this video, and I hope you have understood this video very clearly and you have got to know about the various concepts regarding this, and I hope you'll share this video with your friends, and don't forget to subscribe to Ekeeda channel. Thank you so much.